I'll probably just jump to the next screen. So what we're talking about today is Kubernetes storage. And one of the things I understand is that storage really underpins everything that you want to do on Kubernetes. So all of your applications, most of them will have some state, whether that's you're storing some data in a database, you have some file system, but also a lot of your logging and monitoring metrics and a whole range of other applications. They all depend on having a robust storage kind of solution. So what we're going to do today is just run through some experiences and some work we've done in this space. So within Kubernetes, there's three sort of kind of types or categories of storage. There's what's known as persistent volumes. So these are, it's kind of like an ecosystem. There's lots of different implementations of a persistent volume. And the idea is, as an application, you make a claim for a particular slice of that storage. So you may be running a particular job and you may need 1 GB of disk space. So you would make what's known as a persistent volume claim for 1 GB. And then the persistent volume sort of implementation would provide that gigabyte to you. So as an application, you're largely isolated, so insulated from how that storage is actually managed and provisioned. So then there's kind of another type of storage, which is data grids. So these are sort of your distributed data storage, and typically they're independent of Kubernetes. So this is, I mean, for people that come from a Java background, this is things like, Hazelcast, Apache Ignite, Alluxio, and there's quite a few others. And typically these are just, applications that run on each of the nodes, and they will distribute the storage, distribute the data between them. And then the third type, which is called host paths. So this is just basically where if you're running a particular application, so if you've got a particular application and you've got some pods, it really is just accessing the underlying storage. So what's actually physically on the node itself. So typically if you would have SSDs, then this provides a fast way to access that. So we're going to take an example here of Jenkins. So for those who know what Jenkins is, it's a CI/CD tool for building your code, building and deploying your code. And if we imagine this here, so the blue part would be the application, and the gray part would be, I guess, where Jenkins is storing all of its state, so storing all of its data. And the use case that we have, and it's a very common one, which is that we want to make Jenkins highly available. So we've got this Kubernetes platform. It has this ability to spin up pods automatically on different nodes if one of them goes down. But the challenge there is, how do we deal with the data? So obviously, if we have one Jenkins running on one node, then we need to actually synchronize that data with another node so that if one falls over, all of your state is still there. So there's plenty of options for doing this. And so we actually evaluated all of these. We did quite a few proof of concepts on these. And I'll kind of explain sort of why we've ruled some of these out. So it's probably not as useful for you guys, but we kind of did rule out sort of Lustre and EFS, mainly for, we wanted something a bit more kind of on-premise. Lustre probably isn't the best example here because we were talking about Lustre for AWS, but EFS was kind of a proprietary solution. Likewise, EBS, you can use EBS with Kubernetes, but there are kind of quite a lot of stories of where when you do sort of detach and reattach these EBS, sometimes there are issues, sometimes it's not as quick as you want it to be. So that can sometimes cause problems for applications. In our particular case, StorageOS and Portworx were really great solutions, but are both commercial and actually have quite quite significant like per node costs. So depending on what your use case is, that can be quite prohibitive, but they're both really great solutions. Linstore DRBD is a really old kind of Linux technology. It involves you kind of having like kernel level drivers, which means kind of it's not necessarily something that's kind of like transferable between clusters, or if you upgrade your cluster, it's something that's kind of a little bit more fragile. And so that can be a real challenge, especially with if you're using, say, an AWS Kubernetes platform like EKS, or using Google's implementation. Often they have kernels, Linux kernels, which are somewhat unique. And so that can be a challenge for getting those to work, getting Linstore and DRBD to work on those platforms. Oops, sorry. Okay, so it really came down to three options. One was OpenEBS. The other is one called RUKSEF. So, and the third one is GlusterFS, which is a distributed file system. So I'll go through all three. So we actually kind of just went and kind of ruled it down to two. So we went with OpenEBS versus RUKSEF for doing kind of investigative proof of concepts. So what we found was that OpenEBS definitely is easier to use. So it's easier to install, easier to manage, easier to maintain, easier to upgrade. And it's just architecturally a lot simpler. So RUKSEF is actually two products. And you kind of have to, if you do, for example, find a bug, you've kind of got to dig dive and understand like which of the two components might be having issues. So that kind of makes it a little bit challenging, but it isn't sort of impossible to manage. It's still fairly easy to install. Again, because OpenEBS is really just one component, it's quite simple, and there's kind of a lot less moving parts compared to sort of RUKSEF. It doesn't have the level of features. So RUKSEF can provide you with kind of different views on that data. So it can give you like an S3 sort of style layer on top of it. It can give you an NFS or a file system type layer. So it has a lot more features around things like monitoring and backup and quite a few other things. The real issue with OpenEBS is just the sheer performance. It's significantly slower than all of the other options are presented in the previous slides. And RUKSEF isn't actually a whole lot better. So there are other solutions like the storage, like the Portworx or Storage OS, which are 5-10 times faster. So performance is a real issue when using these products. And again, the bandwidth is really slow. And so if you compare this to an SSD, we're talking, like I said, anywhere from like 5 to 10 times slower, which is kind of a bit of a shame. So what I want to kind of jump into is a different topic, somewhat related, is what's known as NVMe over Fabric. So this is a new technology which has been around for about a year or maybe two, in different forms, but it's starting to become a little bit more popular now. We now have AWS and Google instance types. So if you want to provision hardware with this capability, you can do that today. And what the benefits that it brings is, if you look on the left here, what we have is Jenkins running on top of an SSD right at the very, very bottom. And so in between, these are all the layers that Jenkins, when it's trying to write a file, these are all the different parts of the operating system and the components that it will go through when trying to write that file. And then with NVMe over Fabric, it actually skips all of those components. So it has this way of doing, it kind of has this kernel bypass, and it writes directly into the SSD. So you get significant performance benefits. But where it becomes kind of really, really interesting is, I'll just kind of skip this here. Sorry, this. Oops, sorry. Is when, sorry, this, jump through again. So one of the kind of really interesting options with NVMe over Fabric is that you can actually do this across the network. So what this allows you to do is have Jenkins running on as a pod, running on one particular node, and have the storage living on a different node. And the performance is actually almost identical to running an SSD locally. So what this kind of allows for is architecturally something really quite unique, which is you could, for example, have one Kubernetes cluster which is dedicated to applications, and you could have a separate Kubernetes cluster which is dedicated to storage. And provided they're both running over this NVMe over Fabric networking, you actually get basically comparable performance as if everything was running on the same platform. So what makes this really interesting is if you can imagine for a particularly large company, you may have different teams with running their own Kubernetes platforms where they have their own needs, their own configurations, their own requirements. But you could have a storage Kubernetes cluster which is managed centrally where all of the storage across the whole company is kind of shared and pooled and allows security teams to have that control that all of the company's data actually lives in one place. So it's really interesting. It also has huge benefits for anything data related. So if you're doing, if you're running databases on a different node to where your pods are, you would actually still get identical performance as if the database was locally. And where we've seen really interesting improvements is particularly in Spark. For those that know the data science framework Spark, it's a distributed framework for basically you take a particular data transformation and it breaks it up into pieces and distributes it amongst multiple nodes. That process of distributing it on existing platforms can be quite slow and is often the bottleneck. On this new architecture, we've seen Spark jobs anywhere from 2 to 5 times faster on identical CPUs, identical memory, just with this new networking and this new NVMe over Fabric kind of architecture. So yeah, it has huge potential. It's definitely going to have huge benefits for Kubernetes going forwards. And we're starting to see this technology become more commonplace amongst kind of the lower priced or the cheaper options for instance types. So it's definitely becoming more widespread. All right, so yeah, so this is kind of it's based on this RDMA technology where instead of TCP/IP, we use RDMA. All right, so one of the kind of things I want to mention was that OpenEBS is actually currently rewriting their storage engine to use this new technology. And some of the benchmarks that we've seen show it to be by far the fastest solution, almost comparable to running SSDs. So what this allows you to do is it really gives you that ease of use and that simplicity of OpenEBS, but also now allows you to have kind of the fastest solution. So that's really kind of beneficial now, because what that means is you can start to worry less about whether the storage is going to be suitable and starting to worry just about the applications. So yeah, so this is going forward. Again, NVMe for Fabric is really just as fast as a local SSD, which is really important. Again, especially because SSDs are getting faster and faster and data loads are getting bigger and bigger. So it's really important that you have fast storage. Otherwise, kind of all of your applications will be slower. And again, it allows you for this new architecture. So one storage cluster and then multiple compute Kubernetes clusters. So it's kind of an interesting option. And like I said before, yeah, Spark jobs without any changes will run 2 to 3 times as fast as they do today, which yeah, for many companies is a kind of a really big deal. Sure. So I kind of just wanted to see if there was any questions.
So far so good. I haven't seen any questions come up on the chat. The one question I had was, you mentioned something about Lustre at the beginning when you were going through and filtering down the storage options. Is it Luster? I haven't come across that one. Is there something in AWS, or is there another open source project? Or
yeah, so it is an open source project. However, it's extremely complex to set up and manage.
Right.
So AWS has an option. It's called the Luster for FSX, which is really it's a very, very impressive kind of technology. It allows you to manage. It allows you to kind of mount a remote file. It's kind of like an NFS kind of share, like a remote file system,
right?
But extremely fast. The only challenge is it's just that the cost is quite expensive. So I think there's a minimum cost of maybe a few $100s a month. So that's the only kind of downside.
Right. Okay. Well, if any other questions come up on the thing, I'll post you and probably ask you. Yeah.
Sure.
Yeah. So far, so good. Yeah.
So yeah, it was kind of just a short presentation. Yeah, I was kind of hoping there'd be a little bit more questions. If there's anything people are curious about storage.
Oh, sorry, Mike. Sorry, is that the end of it, or?
Yeah. Sorry, I was kind of hoping it would be a little bit more question and answer.
Yeah, okay. I thought you were going to go through the option of why the chef wasn't selected, or why did you? What were the kind of like the key advantage over OpenEBS versus Rook and Chef?
Yeah, so the advantage of OpenEBS is I'm just going to say I might try and yeah. So the advantage of OpenEBS is it's architecturally simpler. So when you actually install it, kind of install the CRDs, there's less kind of components to it. So Rook is a layer on top of Ceph, so it's kind of like an interface layer. So you're kind of having to install Ceph first, and then you've got to install Rook on top of that. So one of the challenges we had was just, when we saw performance issues or some kind of bugs with some of the writing, yeah, you had to kind of debug both layers. So that was kind of one of the biggest downsides. Also, like I said, I think now that OpenEBS is moving to this NVMe over Fabric approach, it's going to offer that benefit of having excellent performance, but also being architecturally quite simple. So yeah, that's definitely a strong recommendation on the OpenEBS side. Yeah.
So to use the OpenEBS on public cloud, you'll have to have the NVMe enabled by the provider, right?
So the way that works is you don't have to. So there's kind of like a compatibility layer provided for kind of standard clusters like we have today, which is sort of TCP/IP. And then what you can do is, you don't need to you just need to select certain instance types, and then basically install the drivers, and then you will have that NVMe option. But yeah, it's completely optional, if that makes sense. So.
Yeah, and then what disk would you attach to those nodes?
So what was that?
So like say for example in either Amazon or Google, what disk would you attach? Would you still have to attach the local SSD, or could you attach the mounted SSD?
Yeah, so the way you would typically, and this is what makes it such a kind of important area. So if you're building, so just to step back, the use case that we had for this kind of proof of concept was we were looking at our monitoring stack, logging, Jenkins, our databases, our search engines, a lot of these things where they do need a lot of fast access to disk. So they're writing a lot of logs out, or they're indexing things in the case of, Elasticsearch, or for Kafka for the queues. So, but what we wanted was, so we want the local SSDs, which on Amazon is only getting faster. So the performance difference between kind of your host SSDs versus the EBS is becoming more significant. And also you have the option with the SSD, with the kind of instance types to RAID the SSDs as well, which is another option. So what OpenEBS allows you is it kind of gives you that flexibility to not necessarily worry about the underlying storage. You just kind of, as an application, you still use this persistent volume claim approach. So you just ask OpenEBS for 100 gigabytes of data and it will give you that. And then what happens is if your pod dies and gets spun up on a different node, it automatically will have access to, because the data is being continuously synced, it will automatically have access to that 100 gigabytes again. So it just makes building highly available applications almost trivial once you have this in place. It's very, you don't even have to kind of build your applications to be HA. You can just, within Kubernetes, say, look, I want 5 replicas of Jenkins.
Mm-hmm.
And because I will use the same persistent volume claim, as long as you have OpenEBS, you automatically have HA. So you didn't have to build anything. You didn't have to think about it. It was all just done for you. And that's really kind of, once you have that kind of OpenEBS foundation in place, you don't have to, as for developers who are building applications, they don't even need to think about HA anymore. They can just say, look, I want 2 or 3 replicas of my pod, and that's it, it's automatic. So, it offers, I think it's something that I think it's going to become more important as people start to build Kubernetes clusters, that once you have some of these foundation pieces in place, as a developer or someone who's deploying applications, it just becomes so much better and so much simpler than if you were kind of just using normal, EC2 instances or just using normal Docker, where building, having to build a HA solution would be, quite a bit of effort.
So comparatively between the Amazon's EFS or Google File Store, whatever the managed one, which is again highly scalable and all that, price performance, this outweigh or?
Yeah, so EFS is unless you're willing to pay for it, and by willing to pay for it, I'm talking many thousands of dollars a month. EFS is incredibly slow. It would be the equivalent of, like, in some cases, it's equivalent of like a floppy drive or a DVD drive. It's really slow. So that's kind of not really an option for most use cases. So what people have tend to do is or kind of the way it works now, depending on your application. So if you take, for example, Kafka, Cassandra, Elasticsearch, a lot of these solutions will have a built-in kind of clustering kind of option. And so you rely on the applications to do the heavy lifting of managing, the HA, managing, data being moved around. And the problem with that is that, if you're having to worry about this platform, well, each application will have a different approach for that. If, for example, you lose a node that was running, Cassandra and Elasticsearch and Kafka, well, each application, you need to understand what is my approach for managing the consistency or handling that outage of that node, because each one will have a different implementation. Whereas with OpenEBS, what they even encourage you to do is, for example, with something like Cassandra, is you would almost turn off their clustering solution, and you would just have each of the Cassandra nodes kind of talking to this one persistent volume claim. So it's kind of a bit of a game changer in the sense that it gives you that consistency of things like HA across these different applications. So that's kind of something I think a little bit new.
Right. Okay. There's one question from Nilesh. He's apologized, of course, for joining a bit late. And his question is, do you create an OpenEBS and those persistent volume? Persistent volume claims, would they have read-write many access as well? Is it support? Or
So most of them will only support read-write once.
Mm-hmm.
Whereas, so with others, with some solutions like Rook-Ceph, they give you like an S3 layer or an NFS layer, so you can kind of have that multi-access to the data that way. And so what we've done with OpenEBS is it comes built in. I'm not sure if it comes built in, but it kind of comes with an NFS provisioner. So this allows you to have that read-write many option as well.
Right, but
yeah.
Do you lose any I/O performance because it's the added NFS layer, or?
So I haven't benchmarked that particular one. Yeah, it'd be an interesting one to test. But yeah, I mean, I think, yeah, that's kind of always the challenge when you're trying to remotely mount file systems like that. But yeah, that's one to check with the whole NVMe kind of thing as well, whether they're going to get performance improvements with the a rewritten NFS provisioner as well.
Right. The other question from Binura, have you had a chance to look at Longhorn from Rancher?
Yes, so that was one of the ones we also looked at. So it just wasn't on that slide. So I think the issue was just around, I'm trying to remember what the issue was. I think might have been around the performance and complexity. So it kind of didn't have all of the features of like Rook-Ceph, and then it didn't have the simplicity of OpenEBS. So that's kind of why we ruled it out. But like I said, I think
before the GA, or was that before GA, or because I think they only went GA a couple of weeks back.
Yeah, so I think that so I think that was probably a little bit before. But so I should have showed it, but there's benchmarks around where they benchmarked a lot of these solutions together.
Right.
And so you're kind of, it's kind of on one hand it's okay to trade off the performance if you can get some features for it. But then if you kind of don't have either, it becomes a little bit difficult. But like I said, I think with OpenEBS, if the new storage engine lives up to its potential, yeah, it'll kind of be a no-brainer just to use it at this point.
All right. Any other questions from the forum, listeners?
Hi, Naden. So last time I worked with OpenEBS, I remember that there were two drivers called Sister and Jiva. So I mean, what's your take on it? What are the use cases for using Sister versus what are the use cases on using Jiva driver?
I'm trying to remember what they were. So I know one of them, is it the CStore one's the newer one? So they're actually building, this is what I was kind of mentioning, they're building a third one, which is called the Maya Store. So I saw a demo of this already. So it's going to lack the features, I think, of the other two. Well, I think the Jiva one was the earlier one that was kind of more robust and had some additional features, I think, around backup and snapshots and some of those things. But I think one of the concerns was just that it didn't really matter which storage engine you used because they were both so incredibly slow, which was kind of frustrating. Whereas that's why I'm saying I'm hopeful that when Maya Store comes out, which I think is fairly soon, I think in the next few months, hopefully that'll be the kind of more preferred option, I imagine.
So Maya Store also will be open source and free to use, or will it be sort of like an enterprise option? I'm
not sure. Well, it's open source now, so you can check it on their GitHub page. Yeah, I'm still kind of, I wasn't 100% sure how OpenEBS kind of, I'm assuming they provide support and that's how they monetize their product. But I don't think they're going to offer a commercial version, I would imagine. I think it's more support.
All right.
Yeah, but it's definitely open source. You can see what they're up to.
But they do have a separate offering called Maya Data, right? Which is probably the hosted.
Might be a hosted version. Yeah.
Yeah. Right. Yeah. So you reckon the Maya Data store that would still be open source? So,
yeah, definitely. So yeah, I definitely asked this question and wanted to make sure. Yeah, I've gone through the code for it because I was kind of curious how it was all being written. So yeah, and I imagine what's going to happen is like a lot of this technology is just going to move back and forward between the different options. So I imagine I know Rookceph is working on an NVMe over Fabric implementation as well. So I imagine like there'll be huge benefits across to all of them, and as long as they get within 5-10% of what the SSD is on, like the raw SSD, I think it's fine. I don't think most people are that kind of critical, but you just don't want it to be like 5 to 10 times slower. If that makes sense.
yeah, definitely. Yeah. So the only one, if you in yours you recommend OpenEBS for this level of performance and so on and so forth, other than the commercial ones, of course.
Yeah, unfortunately so. And the commercial ones, I mean, the benchmarks for those looked really impressive, but also they were charging per node, and it was, I think it was like $1,000 per node, and that's kind of a little bit. It's harder to deal with when you're in Kubernetes, because the whole point of it is to kind of have a lot of nodes and to auto scale and to do these sort of things. So yeah, that kind of licensing model becomes a little bit tricky. Yeah.
Interesting. It's a challenge for the cloud providers as well, isn't it? Because you're now moving into a different era, right? Asking compared to
Yeah, and it's just, I think everything's going to start to change. I think once if this networking technology does become more widespread, and the data requirements become larger, so everyone's doing more things with more data. There'll definitely be some kind of room. I think the cloud providers are definitely going to get more into this kind of space of providing, faster kind of attached storage, and kind of doing more in the Kubernetes space to integrate more deeply. So I think it's definitely kind of an area to watch.
Yep. Is there another question, Nilesh, or you just?
So I haven't worked with EBS for a while. I think I worked with EBS last year on an OpenStack platform. So when I was working on it, I knew that OpenEBS was working on an iSCSI driver. So my question is, at the moment, right, can we interchange these drivers? Can we use something like a Google Disk or something like that, or like have an S3 layer and then get OpenEBS to do what it does on top of those? Is that possible, or still is it highly tied with iSCSI?
Yes, it's still highly tied with iSCSI, so that's how it kind of synchronizes the data between nodes. So there's not really a way around that. If you need to put S3 on top of it, that's definitely because OpenEBS is quite low level, so you can put things on top of it like Minio. So that's Minio is kind of probably one of the standards. I think you can even put Ceph on top of it as well. It's kind of a bit weird, but you could definitely do that. But yeah, Minio seems to be pretty common, and I think there's a whole bunch of those kind of S3 object store options. Yeah, definitely.
All right.
Yeah.
Okay. And finally, the backups. So it's still running on, I think, FTO Hark is renamed now for Velar or something. So is that still the driver to use backup and restore with when it comes to OpenEBS, or have they developed their own tool or something like that?
No, I think they're still going with Velaro. And I think that's going to be continuing even with their new engine as well.
Okay.
Yeah.
All right.
Yes, that should be interesting.
All right. Any others have any other questions? Otherwise, we can happy to wrap up there. And
Yeah.
Sorry, Nilesh. I mean, if you have any other questions too.
Yeah, a small question. So, like you mostly worked on the data side, yeah. So I see that you have written about Spark jobs, etc. So there's nothing related to the storage side of things. Just a small question. Have you worked on KubeML, Kubeflow, etc. on ML jobs? What's your thought on it? I haven't tried it. I hear a lot of people talking about it. So what are your thoughts on that?
Yeah, I know it very well. So we tried Kubeflow, I think probably about 6 months ago, maybe 9 months ago. So very early. It's the underlying technology. So Kubeflow is really, how to describe it? It's kind of like it's like an orchestration layer on top of a whole bunch of other components. So those other components, for example, it uses Argo workflow for its workflow engine. It uses Seddon Core. I think it's Seddon Core for its ML. So really, the issue with Kubeflow is just that when you kind of install it, you're installing all of the components as well. So you tend to end up with just 100 things going on. So depending on some people, if you're kind of comfortable with it, that's probably okay. And the underlying components are well selected and they work pretty stable and everything looks good. But it can tend to be a little daunting to kind of deal with. And that doesn't look like it will change because that's kind of just the model that they've gone with. So in my last role, this is actually something that I worked on, was I just kind of built something similar to Kubeflow, a kind of much more simple version of it, where I kind of I used Argo workflow, and I used Seddon Core for the ML hosting, and there's quite a few of these kind of components. And so if you actually look through Kubeflow, you'll see all of these components that it depends on, and each of them, you can just integrate directly with. But yeah, one of I think the things that's going to happen is just that it's becoming a little bit like Kubernetes itself, which is that there's a lot of people rallying behind it, a lot of different companies. It's becoming quite a kind of a plug and play thing. So yeah, it'll definitely be really interesting to see what happens in that space, especially because as Kubernetes gets bigger and becomes more widespread especially within the enterprise space, companies are going to look for ML solutions, data science solutions that run on top of Kubernetes. And currently, if you were, for example, like Cloudera or Hortonworks or those kind of, now it's the same company, but if you were those kind of old school Hadoop Spark companies, those don't really run on Kubernetes. I'm not sure if what their kind of roadmap is for getting all that to work, but yeah, I think you potentially could see Kubeflow being kind of the next kind of standard kind of platform going forward, definitely.
Okay.
But it's still very early, that's for sure.
Okay. All right.
Yeah. And so it's just something I'm definitely passionate about working on at the moment.
Okay. Yeah, I'm good. I'm good.
Yeah.
Thank you.
All right. Let me just do a last recap to see if there are any other questions. If not, we could wrap up and thank Naden for taking the time. Much appreciated. And if the community interested to deep dive on one of these, so open the EBS, so if we can convince Naden to come back and probably do a little bit more deep dive and show a few things. I'm happy to talk to Naden and find out whether that is possible. Otherwise, Naden, on behalf of the community and helping the community to grow, get interest around Kubernetes, and coming and giving this talk at sacrificing your late night. Thank you so much again, and
it's a pleasure.
Really appreciate it. And and I'll get the community to stay in touch, and if there is
I've got
other questions
here.
so.
Yeah, so just add me on LinkedIn. Happy to answer any questions, happy to send code, whatever you need me to do. More than happy to help.
All right, Naden, and thank you everyone very much for the others who have joined. And once again, Have a good night, and we'll see you next time.
Brilliant. Thanks, guys.